Hello, we are going to discuss table 12.4, which is this one, and I'm going to tell you how they got these percentages. So to begin with, you know how we can have different ribonucleoside diphosphates which are turned into RNA using polynucleotide phosphorylase in this direction. Also, you know that what's special about polynucleotide phosphorylase is that it doesn't require a DNA template. Therefore, the mRNA which is synthesized is going to be randomly synthesized. So their aim in this experiment was to know what codon codes for what amino acid. So they brought a specific ratio of ribonucleosides diphosphate using polynucleotide phosphorylase and made an mRNA with them. And we know that this mRNA is randomly made. Then they did a translation using amino acids that they have put into the experiment, and tRNA and ribosome. We had the protein, and then they somehow know what amino acids compose the protein in what ratio, and they did this table. Or to be more specific, this side of the table. Suppose that we have a specific ratio between A and C. Here we have 2A and we have 10C, which is 1A to 5C. So if we come to this table, A percentage, so the chance of having A is 1/6, because we have, if we come back here, see how we have 2 A's and the total number is 12. So we're going to have 1/6. So we have 1/6, and the chance of having C is going to be 5/6. I want you to remember that this mRNA that we've synthesized is random. We don't know its composition. So first thing, we got the probability of having each nucleoside diphosphate. Okay, then we are going to see the possible composition. So let's start. I might have 3 A's. So my code would be AAA. So what is the probability of having this code? So how are we going to do this? First, we're going to take the probability of having the adenine, and then we are going to put 3. Why we put 3 here? Because we have 3A. The calculator, this is going to give us 1/216, which is 0.4%. A and 2A. So what are we going to do? So it might be adenine, and cytosine, or it might be adenine, cytosine, and adenine, or it might be cytosine, adenine, and adenine. So now let's take the probability of having any triplet. So for example, the probability of having adenine, I'm going to put 2 because we have 2 multiplied by the probability of having cytosine, which is 5/6, and here we have 1. And using the calculator, we're going to end up having this number. I want to say something that we don't know actually any of these triplet is going to be the one coding for our amino acid. So what does that mean? That this probability is going to be multiplied by 3. So to make this clear, you know how we have this mRNA is going to give me an amino acid? So if we said that the percentage of the specific amino acid in a protein was 2.3, this means that this protein might be this, or this, or this. And why can't I decide? It's just because that they didn't have enough tools to decide. So coming back here, I have the possible composition and these things. So let me tell you that this is not really important. What we are going to see is this one, these compositions. So for example, here we said that the lysine appeared in less than 1%. So what percent in here is less than 1? Well, this one. So lysine is probably going to be AAA. So let's take this one, histidine, for example. the percentage was 14. So, you know, wait a second, let me erase this. Oh, okay, I made things worse. So let me erase this in here. So if we took 2.3 and 11.6 and we add them together, we are going to have 14. So histidine might be 2 cytosine and 1 adenine and all these compositions, or might be 1 cytosine and 2 adenine, which is all this composition. We don't know which one of these, but we just know that it's one of them. Thank you for watching. I hope it was easy for you to understand this, and sorry because the video wasn't really good, because actually we have the final and you know the exam is after tomorrow. So yeah, thank you.